Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to start today electrochemistry. Definition over here is electrochemistry, the process of chemical reaction that produces or requires electric current. Now, we talked about oxidation reduction reactions last year, so if you need to spend a little bit more time going back over there, we're going to run through this real quick because we did cover this last year. That was in Chemistry 1 playlist days 124 to 128. Remember, like, share, subscribe, comment. Any questions helps get it out there. I'm not really interested in getting a whole lot, just to try to help people out. So we're going to begin this process, of course, with oxidation reduction. Definition of oxidation reaction, type of reaction, where balancing is done based on the number of electrons lost or gained. Now, the process we're going to do, remember the acronym we used, oil rig, to help them memorize that. Oil rig stands for oxidation is losing, reduction is gaining. So that being the case, oxidation then is the element that loses an electron. Reduction is the element that gains electrons. Oxidizing agent is defined as the element that causes oxidation by being reduced. So whichever one's reduced, that's the oxidizing agent. And a reducing agent, element that causes reduction by being oxidized. Again, it's the opposite of the last one. The one that is actually oxidized is the reducing agent. All right, so I've got here's the steps. I almost forgot that. There are 5 steps in the process. First, we identify the element whose oxidation numbers change. Remember, they can look at 3 different things. First, to see if it's an element by itself. Second, metals identified as do not know, the ones that are not a set oxidation number we know. And then third, the center atom of a polyatomic ion. That nitrate, that N, the sulfate, that S, things on those lines. Determine electrons lost or gained. Check the number to see. This is the third step. Make sure you check this for each side. If not, multiply by the multiple. And we'll go back and look at that. We're going to go through one of those in the practice here today. And then get the number of electrons lost, equal number of gained, and then balance by inspection. Metals, non-metals, hydrogens, oxygens. All right, so I've got 2 problems up there. I'm going to start with the second one here. Okay, so first thing we do, is there an element by himself? Well, there is iodine, and an element by itself has oxidation number 0. So go on the other side, hydroiodic acid or hydrogen iodide, that would have an oxidation -1. That is a change, so we're going to group that up. Now, the other thing, is there any other elements by themselves? No. Any metals we don't know? No. Polyatomics, yes, we have nitrite over here, NO2, so we're going to go up the center of the atom. This is the only time we break them all apart. Oh, I forgot how many it is. So that's losing 1 from -1 to 0. Now it's losing because electrons are negative. So whenever the number goes up, we're losing. When the number goes down, we're gaining. So let's do nitrogen. Oxygen -2 times 2 is -4. Hydrogen is plus times 1 is plus. So what number that would be? 3 plus is only one of them. So nitrogen is 3 plus. Now we're going to assume we know that's a covalent molecule. But to do this, we assume everything's ionic. Because the other side, oxygen is -2, and that's 2. So +3 to +2. That means as a combined, we're gaining 1. And I was looking pretty good, but we got to remember that third step. Do we have 1 nitrogen? Yes. Do we have 1 nitrogen? Yes. 1 iodine? Yes. 1 iodine? No. It's not even balanced, so let's get a balance first. Put a 2 there. Now, how many do I have on each side? I have 2 on each side, so that's a multiple. So we're going to multiply by the multiple times 2. I'm actually losing 2 electrons. Now get these equal. What's the least common multiple? 2 and 1, that would be 2. So multiply by bottom line 2, and we'll put that in the problem. So put 2 there and 2 there. Now we balance by inspection. There are no metals. Nitrogens, 2 and 2. Hydrogens, 1, 2, 3, 4. Only 2 over here. Let's put a 2 there. Oxygen, 4, 2, and 2. Now last thing I want to do before we finish up is identify oxidation, reduction, oxidizing agent, reducing agent. So oxidizing agent, which one's losing? That would be iodine. Reducing agent, which one's gaining? That would be nitrogen. Which one's causing oxidation by being reduced? Which one's reduced? Nitrogen. And reducing agent was causing reduction by being oxidized. That would be up here. That would be iodine. All right, let's look at the next one. Okay, this reaction, we have potassium dichromate plus water plus sulfur yields against potassium hydroxide plus chromium 3 oxide plus sulfur trioxide. All right, so let's start with the element by itself. Do we have any? Yes, we do. We have sulfur, 0. Now we go to the other side. That's a covalent molecule. We're going to treat ionically. Oxygen is -2 times 3 is -6. So that means that sulfur has to be +6. So 0 to +6, we're going up. That means we're losing 6 electrons. All right, let's go to the opposite side. Any other ones by themselves? Nope. Metals we don't know. Yeah, chromium. Plus it's a polyatomic. So let's go to that polyatomic. Center, we'll break them all apart. -2 times 7 is -14. Potassium +1 times 2 is +2, 2 plus. That means chromium has to be +12, be +6. Go to the other side. Oxygen's 2 negative times 3 is 6 minus, 6 plus. That means each is going to be 3 plus. So going from 6 to 3, we're going down. Therefore, we're gaining. Gaining how many? Gaining 3 electrons. Let's check our third step. Do we have 1 sulfur? Yes. 1 sulfur? Yes. 1 chromium? No. But here they're even, so it should be okay. No, it's still a multiple. It's going to multiply by a multiple. So it's time 2, not gaining 6 electrons. Electrons lost, gain, same. We're good. So start with potassium, 2 and 2. We're good. Put a 2 there. Chromiums are good. Sulfurs are good. Hydrogens 2, 2, and then we're going to put then the oxygen's 14, 15. We have 6, so hold on a second. Oh, it's just 8, sorry. 7 and 1 is 8. 3 and 3 is 6 plus 2 is, that's also 8. All right, so let's go back and look at this last one. We're gonna, I made a mistake. We're not gonna go that. We're gonna finish oxidation, reduction, oxidizing agent, reducing agent. Then you can go through and work on that top one. The video, go through it, try it. Any questions, let me know, ltswpd@gmail.com. All right, give it a shot. All right, here we go. Ready? So we're going to start. Oh, I forgot that. Oxidation, sulfur, reduction, chromium, oxidizing agent, reducing agent. Okay. All right. Okay, so now pause and try this. This one's a pretty simple one. Give it a shot. See what happens. Let's try this one now. So oxygen, sulfur is 0. Sulfur is -2. Nitrogen is going to be +2 and +5. Box them. How many lost and gained? Try that. If you haven't done it yet. Okay, you should get that there. Losing 2, gaining 3. Put a 2 and a 3 in front of each problem. Lastly, check our charges. I got 2 nitrogens, 3 sulfurs, 3 sulfurs. Hydrogens, I have 2 and 6. That's 8. We have 2 over here, so I'm going to put a 4 there. Now check my oxygens. 2 times 3 is 6. 2 and 4, that's 6. Let's do oxidation, reduction, oxidizing agent, reducing agent. Try that on your own. You should get right there. All right, that's it. Not too bad. Going to practice 2 sets tomorrow. Take care. God bless.